As the market for commercial and industrial IoT applications explodes, so too does demand for the communication technologies that enable them. This is especially true for remote sensor applications in which small amounts of data need to be transmitted wirelessly over long distances while using a minimal amount of power. To accomplish that, IoT developers implement one or more low-power wide-area network protocols. Among these, the LoRaWAN standard has surged into a dominant position, but it faces a number of competitors. In this interview with Machine Design, LoRa Alliance CEO Alper Yegin delves into the factors driving LoRaWAN's rapid growth, how it compares to competitive LPWAN technologies, and discusses the direction he sees the LoRaWAN standard moving in the future.
So the wireless communication industry has been filled with several technologies, and Bluetooth, Wi-Fi, and the cellular have been the dominant three of them. Now we have been building the fourth pillar of the wireless communication industry called LPWAN, Low Power Wide Area Networking. There are several technologies under that umbrella, and among them LoRaWAN is the leading one. The LPWAN pillar is very complementary to what you get out of Bluetooth, Wi-Fi, and cellular. Now, among all these four pillars or four technologies, every one of them does something none of the rest can do. Like Bluetooth provides low power, short range communication. Wi-Fi provides short range but broadband communication. And if you need long range broadband, then you would use cellular. For having a long range, low power communication, that's where the LPWAN comes into the picture. And LoRaWAN is the market leader in that for having the highest accessibility, the most robust ecosystem, and the widest adoption. LoRaWAN technology among all the LPWAN technologies has the highest accessibility. We use unlicensed band. That means anyone can deploy it. You don't need to have a extremely expensive and limited license from the government. It's just like Wi-Fi, right? Anyone can deploy Wi-Fi, so can they deploy LoRaWAN. And the LoRaWAN base stations are extremely low cost. The price point for LoRaWAN gateways or base stations is nearly what you get for Wi-Fi access points, both indoor and outdoor. And every LoRaWAN gateway can provide miles and miles of coverage. And once you deploy a network, you can put on several different applications. So there's an increased return on investment. And the sensors can last for more than 10 years on single charge. And these are the factors which makes LoRaWAN deployments extremely low cost. And the technology is built by LoRa Alliance, and it's endorsed by ITU. It's an open standard. And there are several open source implementations. If you want to build your own devices or network, you can start with the open source implementations. For that, we have the highest accessibility. And then the second point is we have the most robust ecosystem. LoRa Alliance, which has been around for 11 years, now we have more than 300 members from all around the world, all the way from chip vendors to multinational public operators. And last year alone, we have added 57 new members, so we have a really good growth curve. And among them, we have more than 650 certified devices, the highest number for any wireless technology in LPWAN. And nearly 1,000 products are in the LoRa Alliance Marketplace catalog. And then in terms of the adoption, we have today 125 million LoRaWAN devices in the field. Excluding China, this is the highest number of LPWAN devices. And we have 25% annual growth, it's exponential growth, which is the highest growth rate across the globe. And the applications, we have the widest range of applications, all the way from tracking black rhinos in African wildlife parks to connecting indoor air quality sensors in skyscrapers in Singapore to vibration sensors in oil refineries in the Middle East to the NBA basketball arena in Atlanta for facility management. These are all real deployments. The widest range of applications for any wireless technology are empowered by LoRaWAN. And one last thing, in terms of the adoption, the highest adoption, we enjoy thanks to being able to create public networks, private and community. These are three distinct types of network models. And LoRaWAN is the only wireless communication technology one can build any one of these types of networks at scale, not only on the ground, but also in space. We have LEO operators, low Earth orbiting satellite operators, with LoRaWAN base stations mounted on the satellites, picking data from sensors on the ground. And the cherry on the top, we're able to integrate them all through roaming. So we have public networks roaming with private networks, with community, with the satellite networks, all getting integrated. So for those three reasons, we have the world's leading LPWAN technology, which is one of the four pillars of the communication industry. So some of them are complementary, some of them are competitive. So in terms of the licensed and unlicensed technologies, LTE-M and NB-IoT are licensed technologies. Sure. They provide wider bandwidth. They can carry larger amounts of data, and they can provide real-time communication. Whereas LoRaWAN does the massive IoT applications for super low cost, long range, low battery consumption applications. That's what LoRaWAN does. And if we look at the IoT landscape, more than 95% of the IoT applications fall under the so-called massive IoT served by LoRaWAN, whereas less than 5% would fall under so-called critical IoT. Either the application requires like gigabytes and terabytes of data, say you want to connect a car or connect an airplane, or you need to have a real-time communication like controlling a drone or controlling a robotic surgical arm, right? That's where you would want to use a license band-based technology like NB-IoT and LTE-M. And as such, they are very complementary. Right now, we have tier 1 GSM operators all around the world deploying a mix of the two technologies. A good example is Swisscom. They have obviously a nationwide cellular network. On top of that, they have a nationwide LoRaWAN network in Switzerland. One of the applications they have is tracking shared bicycles across the nation using LoRaWAN. For being a low-cost choice and a low-power choice, the bike sharing company has chosen the LoRaWAN from Swisscom's product portfolio. So depending on the use case, the operator can offer one or the other, and the customer can pick and choose. Or if you jump to, say, the neighboring France, Orange has a nationwide LoRaWAN network along with LTE-M. For connected cars, they would use LTE-M. For water meters, they would use LoRaWAN. So there's this mix, right? And then if you jump over the fence to the unlicensed band, like you said, there are several other technologies, but like I said, LoRaWAN stands above and beyond in terms of adoption, the ecosystem, accessibility. So yes, there are some applications where you would see the customer needs to make a decision between LoRaWAN and one of those other technologies, and so far, majority of them have been choosing LoRaWAN, as you know the numbers reveal, and as some of those technologies you mentioned have been winding down, and some of them are trying to make an entry into the market. And yeah, so that's the mix basically. There'll always be a mix of technologies, and over time you will see they end up being complementary, whereas numerous competing technologies with overlap, you know, starting to reveal who is the winner and who are becoming marginalized. So that's always been the case, and you know that's a regular evolution of the wireless communication technologies in the field. As we now encounter the AI industry is starting to pay attention to the so-called physical AI, right? You know, traditionally AI has been operating on data that's already in the digital land, processing it, and the output has been something else in the digital land. Now, AI's attention is adding the physical world, how to sense the physical world, process the data, and then command the physical world. And for that, the AI needs to touch the ground, touch the physical land. And that's where the IoT comes into the picture. IoT is the glue that can get AI in touch with the physical world. Mm-hmm. And for LoRaWAN, supporting the widest range of application, we are in a unique position to make physical AI a reality. And we are already doing so in the field in three distinct places. One is on the sensor. we have a group of sensors that are running machine learning on the device, like vibration sensors and the cameras. Instead of streaming the raw data, like the vibration signal or the video streaming, they process the data locally to make a determination like the vibration has deviated from the norms to the point that the rotating machine might be breaking down, or the camera detecting people, pets, smoke, or pandas in the wilderness, things like that. And then just saying, hey, yes, I have spotted a panda, right? Now, we have several companies in LoRa Alliance ecosystem with such sensors that are deployed in the field today. This is what I would call physical AI on the edge. And then the next one is leveraging AI for managing networks. We have companies that has AI-assisted network monitoring tools to optimize the operation of LoRaWAN networks. And the third place is on the applications, mostly residing in the cloud, to process the data, to boost the data analytics and the user experience using AI. One of the challenges for IoT has been how to make sense out of data. We're really great at pulling the data and then carrying it over extremely challenging RF environments and depositing them wherever they should be stored. Sure. But then starts the next phase, how do you process that? That's where AI comes into the picture in a much more scalable way, extracting, from data to information, to knowledge, to wisdom, accelerating this processing, and as such, increasing the utility of IoT solutions, which has been already applied to LoRaWAN networks, and also the user experience. Human beings are not good at processing dashboards. That's really for machines, right? Now with the AI assistance, now people can ask verbal questions, typed or audio vocally, asking, what's the temperature here, or what, tell me which sensor is giving me alarm, things like that. And the AI-assisted IoT systems now have been responding, which again is lowering one of the barriers to the adoption of IoT in general, which we also see LoRaWAN systems taking full advantage right now. And in terms of the concrete work items we have on our evolution path, we have a class of them that helps with adapting LoRaWAN to application domains. The latest of which is integrating LoRaWAN with OPC UA, which is an industrial IoT application framework. And we have recently signed a liaison agreement with the OPC Foundation to have a joint working group to standardize integration between OPC UA and LoRaWAN. And earlier we have done the same thing with the LMS Forum, Alliance, and OMS as well. We have even done joint work with IETF to integrate IP, the Internet Protocol, to run over LoRaWAN. So these are various application domains getting integrated so we can increase our footprint and also obviously serve the needs of these other alliances, which has been either using some wired technology or other wireless technology, and they have been in great need of adding a long-range, low-power version of those, and that comes in LoRaWAN, at the application layer. And then the other front that we're pushing forward is plug-and-play to enhance the plug-and-play experience with both the end-device management and also the infrastructure management, adding new utilities, new APIs to get as close to a truly plug-and-play as possible. And the third one is we're pushing the envelope on making it easier to extend the coverage of LoRaWAN. One part of our vision is to make LoRaWAN ubiquitously available and make it a utility, just like water, electricity, and gas is, right? Mm-hmm. So plug and play and ubiquitous availability are the key for turning LoRaWAN into utility. So we expect in the future the devices to have LoRaWAN as a base connectivity for management, for tracking, on top of whatever other connectivity they may or may not need for other purposes they serve. And for that, turning LoRaWAN into utility through ubiquitous availability is one of our objectives. And for that, we have the evolution of the satellite connectivity, and we're adding other tools like walk-by, drive-by reading. So in the extremely remote areas where it doesn't make sense to place a base station, say there's a countryside, there are a few houses, and you need to do, there are some water meters, right? It doesn't make sense to build one antenna just for serving a house or two. And for that, what industry has done traditionally is to have a drive-by reading, have a mobile base station mounted on a truck or on a vehicle, going around once a month, pick the data and go back and then deposit it in some storage, right? So now this is already possible with LoRaWAN. Now we're working on how to make it even more efficient, so the end devices can have an extended, better lifetime, despite variable presence of LoRaWAN base stations as they come in and go out, right? Now, even though I call it walk-by, drive-by reading, we're even looking into fly-by reading. We have member companies putting LoRaWAN base stations on drones with satellite backhaul. And these flyover gateways, base stations, can pick the data, whether we're talking about serving, say, meters or people getting lost in the wilderness, or some, environmental monitoring in remote areas.